Good morning, everyone. Today's session is all about system call. Okay, so what should be the objective of this particular approach towards system call is? So the major role of any system call is, how would it better help me a role in intercommunicating between the user mode and the kernel mode. Okay, so I will once again emphasize about system definition, system call definition. So a system call it is nothing but making sure that whatever the request that has been happening from the user end towards interfacing to any program files, okay, it has to provide a proper intercommunication from the user mode request to the kernel end. Okay, so we would certainly have various interface levels to any setup file. So the system call should consider as a request to the user that has been done, and it should provide that raise of request to the kernel, and in turn kernel should accept that particular request that has been raised and in turn respond back to whatever the request that has been raised in terms of the requirement from the end user. Okay, so this is the the general diagram of the system call as already discussed. Today once again I will emphasize, if I want to interconnect or communicate to the system by means of command line interface. Let us say, take an example of open. So what will I do is, if a user want to open a particular file, so open is nothing but a command line interface that I use for any Ubuntu or Linux operating system. Okay, so the user just raise a request for opening up of a file. So system call will in turn consider that particular request that has been raised and calls a request back to the kernel. Okay, what will the kernel do? The kernel will definitely will have some address space that has been allocated for the raise of request from the user application end. So the request from the system call will in turn be accepted from the kernel mode, and it will start to implement that particular interface request that has been done. So after the implementation is properly done, it is the it is the response of the kernel to respond with the normal case with the proper result or with the abnormal situation or the abort situation. Okay, so once if it is properly being done, the return will be in turn raised with the proper result to the system call interface, and the system call interface will in turn give the proper result to the user application. So if this is the case, so how would the how would the application that's I was saying you all with the content, right? How would the application interface look like? So this is all about application interface when we take any apps. Okay, so if the user program has raised a request to any interfaces, it can be any application in any mobile app. So what will happen to the particular function call that is being raised by the user end, that will be considered by an application program interface of that particular setup file that is already been saved in a memory. It can be a primary memory or it can be a secondary memory. Okay, so whatever the raise of request that has been done, okay, the application program interface will access that particular request, and in turn what will happen, the system call interface will accept the raise of request, and it will send it to kernel to perform a particular task. Means the functional call will be accepted by application program interface, in turn will be raised a request to system call interface. So, and system call interface will allocate a particular address space with a particular mode bit, and with that particular raise of request that has been done will be passed to the kernel. So after performing certain tasks, the kernel will return the result with the raising a mode bit to 1 with a certain return value. And what will the system call interface will do? A system call interface is being the intermediate between the user mode and the kernel mode. The system call interface will in turn accept the response or the results that is being approached from the kernel end will be provided to the application level. In the sense, it can be user or it can be any and sharing memory access. So this is as I said, I will be taking various block diagrams. This with regard to the application interface level of any apps that we take. So this, the next slide you all are seeing. Hope so. The diagram is a bit not visible. Is it visible now, students? I think it is visible, right? Are you able to see the diagram for dual mode operation? It was a bit low. I think it is fine now. Will you all just reply? Okay, fine. Okay, so what is this diagram is all about what I was trying to say. How how will the interaction that takes place among user, processor, and the kernel level. So now user want to execute a particular set of files. It can be a process of a program or the entire program file. So what will happen? He will call for a system call. So the system call will in turn raise a request to the kernel by trapping a mode bit to 0. So what will the kernel do? The kernel will see where is the address space that is being allocated for that set of execution to be done for that particular process, and it will in turn execute that process system call that is being done. So after the process request is completely been done, it will return the mode bit to 1. Means if the mode bit is returned to 0 again we have to raise a request from the user end. If the mode bit is returned to 1, what will happen? It is stating that the procedure of the process is properly being executed, it's properly been terminated, and then the mode bit is returned back to 1. So, and after that, once the mode bit is returned back to 1, it will properly be terminated from the user mode also. So we have totally of two mode ends. One is user mode, the other one is the kernel mode. The kernel mode will do all the operations to whatever the raise of request that has been happening from the user end, and user end will only raise a request for the execution to happen. Okay, so whatever the current Windows operating systems that you all are seeing, it is it is monolithic in nature. This is what we call it as a dual mode operation. Means there has to be a proper intercommunication between the user mode end and also the kernel mode end. If one fails, then definitely we have to again recall the same set of executions to be happening. So this is all about the dual mode operation. Okay, you can see at the right end that by default, the user mode will be set to 1, and the kernel mode will be set to 0. So when the system is being called, it will trap the user mode to 0 and will convert the mode bit to 0. Okay, and once the execution of the system call is done, it will convert mode bit to 1 to state that the system call is properly executed. Okay. I'm will you all, this is someone who is this is someone who is disturbing me. Can you just make yourself mute? Okay. Yeah. So this is the overall. Idea of the system call. We will also deal with the types of system calls with the different operating system in the coming class. It is one tabular format, I can say, which has been divided with the types of system call within Windows operating system and the types of system calls that we have observed with the Unix operating system. And it is being categorized on the basis of the process management, on the basis of the memory management, on the basis of storage management. Means storage management in the sense it is with regard to file system. Okay, so that I would be taking in the coming class. Okay, so I would also start to teach with the second unit by taking that particular tabular format. Okay, so you people have any doubts with regard to today's class? Okay, you all have to be knowing this particular general diagram. This is very important. Okay, I'm just opening that particular general diagram. This I've already discussed with you all. I think will not much emphasize on this. This is the diagram that has been taken as an example in the syllabus. And apart from that, we certainly have, we can just take an example, this as an example to explain the system call interface with regard to the application interface of any mobile application. Okay, and this you can take a consideration also for operating system operation and also for the system call operation. Okay, so apart from this, we have something called as the tabular format for the different types of system calls when it comes to the operating systems, Windows operating system and the Linux operating or Ubuntu operating system. Okay, Unix operating system. So I will just be taking that particular tabular format. If yeah, let me again say that this is the overall content about system calls. If you all have any doubts, please do